Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at multi-pure ammonia in water. Most of us know ammonia as a helpful household tool used in cleaning solutions to get our homes sparkling clean. But what about ammonia in our water supply? That's not something we might have thought of. We wouldn't fill a glass of ammonia and drink it, as that'd be hazardous, so we probably don't want it coming out of our kitchen faucets either, which is perfectly reasonable. So, is it present in our drinking water? And if so, how does it affect the water quality? And what happens with that? And they'll actually explain what it is, how it affects your water, how to detect it, and all the information you need to know. So, ammonia, or known chemically as NH3 or NH4+, is a chemical compound of hydrogen and nitrogen, and its several forms of nitrogen are present in many aquatic environments. It's colorless, strong-smelling, and it's highly soluble. It's found in low levels in nature and the human body, and commonly in many household and cleaning solutions. Many glass floor and counter cleaners have an ammonium base, and about 90% of it is produced industrially. It goes into fertilizer, and ammonia is also a component of human and animal waste and is responsible for strong, sharp odor associated with diapers, feedlots, and other places where urine and fecal matter are found. Also, it estimates and suggests the average adult consumes 18 milligrams of ammonium per day with no ill effects. So some of it, their small amounts, are not going to harm you. Since it's a natural product of breakdown of protein, ammonium is also produced daily in our bodies, and we digest proteins. So keep in mind some things like ammonia can affect us without any issues. They occur in our bodies, and there are other issues where if they're in your water, in your food, they're going to cause problems. Ammonia can also be found in most water sources as a byproduct of organic decomposition processes, especially the decomposition of proteins, which contain nitrogen. For example, the decomposition of a deer or squirrel carcass in the forest may produce some ammonia. So does the decay of a fallen tree, and most ammonia in soil accrues as bacteria breaks down into organic matter. Ammonia exists in either one of two forms, and it can exist in pure unionized uncharged form, and 3, or it can exist positively charged hydroxide ion, N4, when it dissolves in water. The form ammonia takes in water is highly dependent on the temperature and pH of the water, and warmer water will contain more of an unionized form and less of an ionized form than colder water, as water with higher or less acidic pH. So, high levels of ammonia in water can have a significant environmental impact. What causes that? Well, it often comes from agricultural, fertilizers, and industrial processes, waste that contain ammonia that gets into surface water in the runoff. So what's the normal level? According to the WHO, the natural levels of ammonia in groundwater are typically 0.2 milligrams per liter, sometimes 0.2 parts per million. Higher levels than that of up to 3 milligrams per liter are often found in forests or areas with substantial iron deposits. Now, the toxicity of it, in water, some ammonia breaks down to form ammonium iron plus ions, and it's toxic to aquatic life. But ammonium ions are not. Generally in water, the equilibrium exists between the two types of ammonia, and the molecules change back and forth between two states depending on the pH and water temperatures. The acidic pH of 6, for instance, the ratio of ammonia to ammonium, is about 1 to 3,000. And a basic pH of 8, ratio declines sharply from 1 to 30. Also, there's ammonia in water. It's non-toxic to humans, but is toxic to aquatic life, unlike other forms of nitrogen, which can indirectly harm aquatic ecosystems by increasing nutrient levels and promoting algae growth in the process known as eutrophoretin. Ammonia has direct toxic effects on aquatic ecosystems, and that will eventually come back to us. Aquatic plants can absorb ammonia and incorporate it in some forms of molecules or structures, and once they have absorbed it, it's challenging for them to excrete it. And it tends to build up in their tissues, and it kills them. Additionally, high levels of ammonia in lakes and streams can promote the growth of algae, which in turn can choke out the growth of other aquatic plants, and bacteria can also convert ammonia and water to nitrate in a process known as nitrification. And it's a beneficial process if it takes place in soil, but plants can use nitrates as food. So how does it affect the water quality, which is the big question? Ammonia in drinking water can sometimes create an unpleasant taste and smell, which is caused by the formulation of chloramines, which the addition of ammonia helps promote. Chloramines formed when both chlorine and ammonia are added to drinking water to disinfect it, and the water has become contaminated with fertilizer, chemical runoff, or animal waste may contain increased levels of ammonia. Because of its lower toxicity to humans, the EPA has not set a standard upper limit for ammonia in public water sources. Local environment limits for ammonia in drinking water throughout the United States range from 0.25 to 32.5 milligrams per liter. The WHO, like the EPA, considers the amount of ammonia regularly found in drinking water to be of minimal concern for human health. For that reason, the WHO has not issued specific health-based guidelines for the levels of ammonia in drinking water. So, water quality recommends for ammonia, the nitron magnitude, the EPA recommends a short-term concentration of 17 milligrams TAN per liters of water. The chronic criterion magnitude, the EPA also recommends a long-term concentration of 0.9 milligrams per liters of water and 4-day average. The EPA also recommends that the highest average concentration across 4 days of the 30 time frame should not exceed 4.8 TAN. We also have associated contaminants. Now, is it in drinking water? It actually is. Municipal water systems have been using ammonia as drinking water for over 70 years and boosts and prolongs the beneficial effects of chlorine. And while chlorine and ammonia are added to drinking water, they react to each other to form chloramine. And the free ammonia exists in different proportions of ammonia and ammonium as well. Now, you definitely want to be sure you look at signs of it like taste, odor, particles in water, low chlorine levels, low pH of water, and bacteria growth. And you can actually see that ammonia can be helpful in some instances, but very harmful in others. That's why it's always a good idea to periodically test your water for higher levels of ammonia in water.